Okay, guys, ladies and gents, up here, we're going to do 2.3 in two parts. We're going to do 2.3 part 1 today, and like I just said, there's 12 questions on your web assign. 10 of them pertain to what we're doing today. The other 2 pertain to what we're doing tomorrow, so you can get all of that done. You should have time in class to work a little bit. We're going to do long division and synthetic division today. I know everybody in Algebra 2 saw this. If you took college algebra last year, you saw it. It may not have been your favorite thing in the world to do, but you did see long division. So let's go back to 3rd grade for a second. Okay, everybody transport back to 3rd grade. Do you remember having a problem that looks like this? And you had to do long division, right? And what did we say? We said, okay, 3 goes into 1. It doesn't, right? So then you said, okay, 3 goes into 12. How many times? 4 times. So I put the 4 right up here. And then what do I do with 4 and 3? I multiply them. So 4 times 3, and I got 12. And then what would I do? Subtract. I get 0. And then what do I do with the 8? I bring it down. And then I do the whole thing all over again, right? You say 3 goes into 8. How many times? 2. So then I multiply 2 times 3, and I get 6. I subtract, and I get 2. And then I bring down. There's nothing left to bring down, right? 2 is called your remainder. When you were in 3rd grade, you might have gone like this, R2. And then you grew up a little bit, and you're like, oh, we don't put that anymore. We would say 42 and 2/3, right? You put the 2 over what you divided by, and then you moved on. We are doing the exact same thing today with division of polynomials. This is not a terribly difficult concept. It is a pain in the butt. Totally agree. You will have one of these on your quiz that says you must use long division, so you have to do it. But understand what the question is asking here. One of your web assigned questions is just like this. It says divide the polynomial, blah, 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 and use the result to factor the polynomial completely. So what they're going to look for is they're going to look for your factors in parentheses, and I'll show you what I mean. But the way that we set this up, what's going to go outside of our division bar and what's going to go on the inside? X minus 2 goes outside, great. And then on the inside, we have 6x cubed minus 19x squared plus 16x minus 4. It is imperative that you guys take your time and that you stay organized, because one little slip of a negative sign and this whole thing explodes. If you do get lost in the middle of it, my suggestion is to erase and start over. Don't try and find your mistake. You'll waste a lot of time doing that. Now, before we start division, we have to make sure that all of our exponent spaces are accounted for. What I mean by that, what's the highest exponent you have here? 3. So there needs to be a placeholder for every exponent below that. I have an x cubed. Do I have an x squared? Yes. Do I have an x to the first power? And do I have a constant? If there's a gap, if you went from like 3 to 1, you'd have an x squared, you'd have to put a 0 in for a placeholder. It's really important. We'll do one of those. But the way that we do long division, when I go to check yours, this is what I do. I say first term into first term. So over here, just give myself a little picture. I have x times what gives me 6x cubed? 6x what? Squared. So I'm going to write it right here above my 19x squared. Keep everything organized. And before I multiply, I'm going to get my subtraction set up like this. And there's a really specific reason why. Right? Just get your subtraction set up. Now you multiply. You're going to say 6x squared times x gives you 6x cubed. And then I'm going to say 6x squared times negative 2. And I get negative 12x squared. Everybody with me? Guys, before you can subtract, because you're subtracting a polynomial, what do you have to do with that minus sign on the outside? You have to distribute it. At this point, you have to distribute that negative. If you don't, it throws the whole problem off. So this would become a plus, a minus, and a plus. Everybody see that? Every single time you have to distribute. Now, once we do that, we can subtract. What's negative 19x squared and a positive 12x squared? What kind of 7? Negative 7x squared. What happens to my 6x cubes? They cancel. And then what do I do with this plus 16x? You bring it down. Good. Now we do the exact same thing. You're going to look and you're going to say, okay, I need to go first term, which is x, into first term. So x times what gives me negative 7x squared? Negative 7x. Okay, I agree. So minus 7x. Before you subtract, go ahead and get your subtraction set up so you don't forget to distribute. So now we're going to multiply. Negative 7x times x is negative 7x squared. Negative 7x and a negative 2 is plus 14x, right? And before we can subtract, what do I do with that negative sign? So change, change, change. God bless. So now 16x minus 14x gives me 2x. What happens to my 7x squareds? They cancel. And then what do I do with minus 4? You bring it down. And guess what? We get to do this all over again. How amazing is this? Super fun, right? Bless you. First term into what? First term. So I say x times what gives me 2x? Positive 2, yeah? So plus 2. Now, before I do my subtraction, if you guys notice I keep saying the same thing, God bless you, over and over and over and over again. Get your subtraction ready so you remember to distribute. So now when we multiply, 2 times x is 2x. 2 times negative 2 is minus 4. And then what do? Distribute, distribute, distribute. So what happens with a positive 4 and a negative 4? What happens with a positive 2x and negative 2x? So what do you guys notice about this problem? There's no what? There's no remainder. There's no leftovers. We're going to use that a little more tomorrow when we have no remainder. We really like when there's no remainder. That probably won't happen a lot, but we really like when there's no remainder. So this question asked you to use the result to factor the polynomial completely. Well, one of the factors we know was x minus 2, because that's what we divided by, right? So then I have this resulting polynomial, 2x squared minus 7x plus 2. Can I factor that more? What's 6 times 2? 12. What are the factors of 12? That'll multiply to give me 12, but add to give me negative 7. I was about to tell you. Okay, minus 4 minus 3. Problem here, though, is my a term is not 1, so I have to divide both of those factors by my a term. Do either of those divide nice and pretty? No, but do they simplify? Yeah, I can change this to 2/3, right? And I can change this to 1/2. So my other two factors, along with x minus 2, would be 3x minus 2 and 2x minus 1. So what would happen if I multiplied all three of these together? What should I end up with? What we started with, right? The 6x cubed minus 19x squared. So on WebAssign, I think it's like the second or third question. The directions are exactly the same as this question. It says to use long division and then to write your answer, with the remaining factors. So you include what you divided by, and then you include the parentheses of your answer. That's the way that the format is looking for, just so you guys are aware. Questions? How many of you guys remember this? Remember seeing it? You're sitting here thinking, God, I hated this last year. It's okay. It's fine. I understand. It's just one of those things that we got to get used to. So we're going to do a couple more examples, then we're going to move on to our synthetic division. So help me set this up. What goes on the outside? What goes on the inside? Perfect. X minus 8 on the outside. And on the inside, I have x squared minus 74. Check. I'm not doing this on Notability. That's why I spread it out already. But check. I start out with x squared underneath. Is there an x represented? No. We have to have a placeholder for it. You can write plus 0x or minus 0x. It doesn't matter. But every single exponent below the highest one that you have has to be accounted for. And if you don't do that, then your division gets all messed up. So as we go to divide, guys, we go first term into first term. So x times what gives me x squared? X. I'm going to put it right here above my 0. Before I subtract, let's get this situated. Now multiply. X times x is x squared. X times negative 8 is negative 8x. See, if you didn't have that placeholder, it would have said negative 74 minus 8x. Then you guys would have said, well, wait, this doesn't work. You have to have that placeholder. So before, guys, we go ahead and subtract, what do I need to do with that negative sign? Distribute, distribute, distribute. So 0 plus 8 gives me 8x. What happens to my x squareds? They cancel, and then I bring down the 74. Now, I know as I do this, you guys are like, man, this isn't that bad. And then when you go to start one, you get yourself a little confused. That's why I want you guys to start it while we're in class so I can kind of troubleshoot and help you. So we, again, first term into first term. X times what gives me 8x? 8, right? So plus 8. So get your subtraction ready before you multiply. 8 times x is 8x. And 8 times negative 8 is negative 64. Before you subtract, what do? You change, change, change. We're going to distribute. So negative 64 and negative 74, excuse me, and positive 64 is negative 10. My x's cancel. Do I have anything left to bring down? No. So negative 10 is my remainder. The way that we would write our answer is x plus 8. It's a negative 10, so it'd be minus 10 over, what did we divide by? X minus 8. Perfect. Can you factor that? No. God bless you. It doesn't factor because it has a remainder. Okay, you guys are doing great. Let's do the next one. Set it up for me. 2x plus 3 on the outside. Agreed. And then the inside I have 2x squared minus 17x minus 38. Before we get started, let's see. My highest exponent is x squared, so the next below it I should have an x and I should have a constant. Do I have that? Yes, so I don't have to worry. I don't have any placeholders I have to put. So guys, first term into first term. 2x times what gives me 2x squared? Just that. I know what you meant. You're fine. So x, I'm going to put it right here above my negative 17x. Keep everything organized. And then before we multiply, let's get our subtraction set up. So I have x times 2x is 2x squared, and x times 3 is plus 3x. But before we subtract, what do we have to do? Distribute, distribute, distribute. Change, change, change. So negative 17 and negative 3 gives me negative 20x. What happens with my 2x squareds? They cancel. And then what do I do with negative 38? We bring it down. This is like Groundhog Day. Then we get to do it again. Same exact thing. We're going to go 2x into negative 20x. So 2x times what gives me negative 20x? Negative 10? Okay. So minus 10. Before we subtract, let's go ahead and get this ready. Negative 10 and 2x is negative 20x. Negative 10 and positive 3 is negative 30. And before I subtract, what do? Distribute the negative. Change, change, change. So negative 38 plus 30. Negative 8. My 20x's cancel. And then do I have anything left to bring down? So negative 8 is my remainder. I have x minus 10. And then I have minus 8 over 2x plus 3. Again, this is not just going to make your brain explode because it has to work so hard. Is it a pain? Yes. Can it get really annoying if you forget one little thing and then everything gets all messed up? Yes. So just take your time and try to stay as organized as possible. But exactly like that is just what we're looking for. Questions? All right, now we're going to talk about synthetic division. All right, this is explaining the difference or kind of like the parts of our function and how we divide the remainder, the quotient, the divisor, that sort of thing. We've already been through that. When we talk about synthetic division, raise your hand if you guys remember synthetic division. Okay, it's a nice little shortcut. It's just an algorithm. You bring down the first term, you multiply to the corner, you add down. Multiply to the corner, you add down. right? You have a little bit of a setup. Over here is our k. This is what you're dividing by. You just set it equal to 0. Then we're going to write out the coefficients of our polynomial. Do you understand, guys, when we are dividing, like we have 2x cubed plus whatever, and we're dividing by x plus 3. When I go x into 2x, how many times does x go into 2x? 2x what? 2x squared. Because you're dividing, right? You're dividing one of the x's into the rest of the problem. Your answer always starts 1 degree less. That's going to make a difference here in a second, but you're always going to start 1 degree less. So let's just talk about some synthetic division. All right, use synthetic division to divide. If you want to use long division to check it, you're more than welcome to. But we're going to synthetically divide here. So the first thing I'm going to do is take my divisor and set it equal to what? 0. So I am going to say x equals what number? -3. That means I'm going to come up here and I'm going to stick -3 in my corner. And then I'm going to write all the coefficients of my polynomial. Remember, if there is not one represented, what do we put? A 0. So the highest exponent I see is 4. Correct? What's the coefficient of x to the 4th? 1. Then I say to myself in my head, since I have an x to the 4th, I should then have an x cubed. Yes? What is the coefficient, guys, of x cubed? 0. There isn't one, so we put a 0. If you forget that, everything is wrong. What's the coefficient of x squared? -10, the sign goes with it. What's your coefficient of x? -2. And then what's your coefficient, or what's your constant? Perfect. Now, we're going to get this party started. Woo, synthetic division. You always bring down the first term. So bring down your first term to 1. We're going to multiply to the corner and then add down. Multiply to the corner. So what is 1 times -3? What is it? -3. And now we're going to add down. What is 0 and -3? -3. Again, guys, multiply to the corner. What's -3 times -3? +9. Add down. What's -10 plus 9? -1. Good. So now I take -1 times -3. You multiply to the corner. You get what? 3. And we're going to add down. What's -2 plus 3? 1. Multiply to the corner. What's 1 times -3? -3. Now we add down. What's 4 -3? 1. Well, that doesn't look like an answer to me. Anybody remember what that gave us? It's the coefficients of your answer. Remember, we started off with x to the 4th. When you divide, your answer always starts 1 degree less, correct? So this is my x cubed coefficient. This is my x squared. This is my x, my constant, and my remainder. So you would write your answer as 1x cubed. You can put the 1 if you want to. You don't have to. Minus 3x squared minus 1x plus 1. And then I have a remainder of 1. Well, what do I put the remainder over? X plus 3. Good. Your answer always starts 1 less than the highest degree of the polynomial you started with. It's just a pattern. You bring that first term down, multiply to the corner, add down. Multiply to the corner, add down. Let's do these next two. First of all, what's my first step? How do I figure out what's going in the little corner box? How'd you get 8? 8, Michaela. Did you say 8?
Yeah.
How'd you get it?
It's the opposite.
You're right. Okay, it's the opposite. You set that equal to 0, right? You said x minus 8 equals 0. So I knew I was going to plug it. I was going to use positive 8. Perfect. So now I take my positive 8, and now I write out the coefficients. What are the coefficients of my polynomial? 1, -7, -11. Do I have any gaps that I need to account for? Put a 0. No. So bring down that first term and synthetically divide. What's 1? Go to the corner. Multiply. 1 times 8 is 8. -7 and 8 is 1. 1 times 8 is 8. -11 and 8 is -3. Is there anything else left? No? Okay, so now I look and I say, all right, well, my problem started off with x squared. That means my answer is going to start with x to the first. So my x, constant, remainder. So write my answer, please. X plus 8. Oh, I don't know why I put 8, sorry. Yeah. X plus 1 minus 3 over x minus 8. Great, guys. Perfect. All right. Synthetically divide. What goes in the corner? -5. Where did we get that from? We set our divisor equal to 0. So now I write out my coefficients of y. I have 1, 10, and 18. Any gaps or anything? Nope. Okay. Bring down that first term. So 1 times -5, -5. 10 and -5 is 5. 5 times -5, -25. And then what's 18 and -25? What kind of 7? -7. Good. So since I started with y squared, my answer is going to start with y to the first, constant, remainder. So I have y plus 5 minus 7 over y plus 5. Good. Last little bit I want to talk about, guys, is the remainder theorem. It says the remainder theorem obtained in the synthetic division process has an important interpretation as described in the remainder theorem. If you use synthetic division and your remainder is 0, that means that whatever you're dividing by is an x-intercept, is a 0 of the function. Sometimes we can't factor things. It's like x to the 5th, and we don't know how to factor those, so we use synthetic division to find the zeros, to find the solution to the roots. So we're going to do that a lot tomorrow. But the remainder theorem just says when you divide synthetically by whatever you're dividing by, like the x value, and your remainder is 0, then yes, that is a factor, or no, it's not. So if I'm asking you to solve something using the remainder theorem, what's the only part of my answer that I care about? The remainder. Please be mindful. Pay attention to what I'm telling you guys so you answer this question correctly. We're going to do the exact same thing that we just did. It's just a little simpler here because they're not telling you that you're dividing something by a specific polynomial or specific binomial. They're saying, evaluate this. Use the remainder theorem to synthetically divide when x equals -2. So what you're doing is you're seeing if x equals -2 is an x-intercept on this graph. And the way that you would do that is they tell you, okay, use -2. So I'm going to plug in. I'm going to use my coefficients 3, 8, 5, -7. Do I have any gaps? No. So bring down your first term, which is 3. Multiply to the corner. What's 3 times -2? -6. Add down. What's 8 plus -6? 2. Perfect. What's 2 times -2? -4. Add down. 5 and -4 is? Good. 1 times -2 is? So -7, -2 is? -9. So is this an x-intercept? No, because the remainder is not 0. But if you're using the remainder theorem, the way that you answer this question is you would say, okay, f of -2. When I synthetically divide using the number that they told me, what is the remainder? -9. Does everyone see the format of that answer? On your quiz, when it says using the remainder theorem, that means, okay, the only thing I care about is the remainder. That's how you have to answer your question. You're telling me, okay, I understand. I synthetically divided by whatever, and this is the remainder that occurred. Questions? Do you see here on the next examples where you have k equals 1 and a equals 5? If you want to use f of whatever every time, that's fine. Don't worry about the specific letters. But how do I solve this? This is using the remainder theorem. So what am I going to put in the corner? A 1. Good. So I put my 1 in the corner. Then I write out the coefficients of my polynomial. So 1, what's wrong with my 1, -7. I have 1, -7, and 10. -7, what's wrong with my... I'll upload this.